Hi guys, welcome back to my channel. If you are new here, I am Rusiru, a software engineer. In this video, we will talk about OSI model and TCP IP model. Imagine you are sending a letter to a friend in another country. You write your message, put it in an envelope, address it, give it to the postal service, and somehow it travels through multiple postal systems across borders and arrive at your friend's mailbox. The OSI model works similarly. It's a 7-layer framework that breaks down the complex process of network communication into manageable, specialized layers. Let's start at the top of our user-facing layer. Layer 7, the application layer, is where you interact with the network. This is your web browser, your email client, your messaging apps. The protocols here, like HTTP for websites and DNS for finding web addresses, are the one that directly serve your needs. Think of this as writing your actual message. Layer 6, the presentation layer, handles data formatting, encryption, and compression. It's like deciding what language to write in and whether to encrypt your message for security. This layer ensures that data from one system can be understood by another, even if they use different encoding methods. Layer 5, the session layer, manages the conversation between applications. It establishes, maintains, and terminates communication sessions. Think of it as the rules for taking turns in a phone conversation. Who talks when, how long to wait for a response, and when to hang up. Now we move to the network transport layer. Layer 4, the transport layer, is often called the heart of OSI because it ensures reliability end-to-end delivery. This is where TCP and UDP operate. TCP is like registered mail, it guarantees delivery and confirms receipt. UDP is like regular mail, faster but without delivery confirmation. This layer handles breaking large messages into smaller segments and reassembling them at the destination. Layer 3, the network layer, is all about routing. This is where IP addresses live and where routers make their decisions. It's like the postal system figuring out the best route from New York to Tokyo, which carrier to use, which paths to take through different countries. Finally, we have the physical foundation layers. Layer 2, the data link layer, handles communication within a single network segment. It manages MAC addresses and creates frames for local delivery. Think of this as your local postal office sorting mail for your neighborhood. Layer 1, the physical layer, is the actual infrastructure, the cables, the wireless signals, voltage levels, and physical connections. This is the trucks, planes, and ships that physically carry your letter. The beauty of this model is modularity. Each layer has a specific job and can be developed independently. A web developer works similarly at layer 7. Network engineers focus on layer 2, 3, and hardware engineers work on layer 1. Problems can be isolated to specific layers, making troubleshooting much more systematic. The OSI model is brilliant for understanding network concepts, but there's a simpler, more practical model that actually runs in the internet, the TCP IP model. Let's see how these models compare and why TCP IP became dominant framework for real-world networking. While the OSI model is excellent for understanding networking concepts, the real internet runs on something simpler and more practical, the TCP IP model. Think of OSI as the theoretical textbooks and TCP IP as the actual implementation guide. TCP IP consolidates 7 layers into 4, and this simplification isn't arbitrary. It reflects how networks actually work in practice. Let's walk through these layers. The application layer in TCP IP is like a Swiss Army knife. It combines the functions of OSI's application, presentation, and session layers. This is where your familiar internet protocols live. HTTP for web browsing, FTP for file transfers, SMTP for email, and DNS for translating domain names to IP addresses. The consolidation makes sense because these functions are tightly integrated in real applications. The transport layer is where the magic of reliable internet communication happens. This layer offers you a crucial choice, TCP or UDP. TCP is like a careful library. It checks every book in and out, maintains perfect order, and guarantees nothing gets lost. It's perfect for web pages, email, and file download where accuracy is paramount. UDP, on the other hand, is like a newspaper delivery service. It's fast and efficient but doesn't guarantee every paper reaches every doorstep. It's ideal for live video streaming, online gaming, and real-time applications where speed matters more than the perfect accuracy. The internet layer is the head of global connectivity. This is where IP addressing happens. Every device on the internet gets a unique IP address, like a postal address for digital world. The internet protocol makes routing decisions, determining how data packets should travel across different networks to reach their destination. It's like having a GPS system for data that works globally. Finally, the network access layer combines the physical and data link functions. This handles the actual physical transmission, whether that's through Ethernet cables, Wi-Fi radio waves, or fiber optic light pulses, and manages the local network addressing using MAC addresses. Here's why TCP IP won over OSI. It was built from working protocols, not theoretical specifications. When the internet was being developed, TCP IP was already proven in real networks. It's more flexible, robust, and simpler to implement. Plus, it's an open standard. No single company controls it. The key insight is pragmatism over perfection. TCP IP demonstrates that sometimes a practical working solution beats an elegant theoretical model. This is a lesson that applies throughout software engineering. Perfect design often loses to good enough solutions that actually get deployed and used. Now that we understand the frameworks that govern network communication, let's dive into the specific protocols that power the web in the next video. We'll explore how your browser securely communicates with web servers and how domain names get translated into IP addresses. If you have any questions, please leave it in the comment section. Don't forget to like and subscribe as we continue this series and building a solid knowledge on system design. I will see you in the next video. Thank you for watching. Have a great week.